The 1949 Nobel Prize in Physics went to Hideki Yukawa. Hope I'm pronouncing that right. Um, it was a really interesting prize. It sounds a little bit like, okay, who cares? But when you hear what it does and how important it is, it's really going to make a difference. But he won it for his prediction of the existence of the Meson on the fundamental basis for the theoretical work of the nuclear forces. So that's a really interesting topic and one that we really didn't completely understand. So when he did this work, nuclear stuff was all new. Physicists were all running around just kind of like throwing anything they can against a wall trying to see what sticks. But his theory was first published in 1935 and explained the interaction between protons and neutrons, which nobody understood at that point. And it was one of the reasons he became a major influence on the research into elementary particles. Now, Meson is an interesting little thing. And when I say little, I mean really, really little. Now, what the heck is it? Most people probably haven't even heard of it before. So let's dig in a little bit and see what a meson is, and more importantly, why do we care?
Now, if you think about the voyage of discovery scientists go on, it's never quite complete. There's always more to the universe we can find out. And as we find out more, we advance our technology and we advance our society. Now, if you think about it, for a long time, the smallest thing in existence was thought to be the atom, but it turns out you can get smaller. We dug in, there's protons, there's neutrons, there's electrons, and of course, everybody thought, well, those must be the smallest. Well, it turns out they're not. It gets smaller from there. So let's go a little deeper. Now, this is not an actual image of a meson. This is an artist rendering of what they look like when they are annihilated, but let's dig in a little bit. So the nucleus of the atom is held together by the strongest known fundamental force of nature, known as the strong force. Professor Yukawa assumed this force was carried by a particle and that there's a relationship between the range of the force and the mass. He referred to it then as the theoretical particle as a meson, and it was finally observed in 1947, 2 years before he won the prize. Mesons themselves are referred to in the physics community as hadronic subatomic particles, and they're composed of an equal number of quarks and antiquarks, usually around one of each. They don't survive very long outside of the nucleus. They kind of annihilate very, very quickly. But it gives us a chance to really study quarks. So mesons actually do serve as an opportunity for us to look at the quark behavior and what they do. Now, what the heck's a quark? Well, a quark makes up a meson. 3 quarks make up a proton or a neutron. And a quark is now thought to be the smallest particle out there. Sound familiar? Okay, there are some particle physicists who are going to go, yeah, well, there's some smaller. What I'm saying is these are thought to be fundamental particles, and there's nothing, they're not comprised of anything else. We're not going to eventually split a quark apart and realize it was made up of 3 smaller things. At least that's the prevailing theory. Now, if that's true or not, perhaps only time will tell, because as we've seen in this video, every time we think we found the smallest thing, we split it apart and a whole bunch of crap comes out. So, who knows? In time, we may find something even smaller.
So, who cares about quarks and all these subatomic, smaller than a proton things? Well, if you think back to earlier Nobel Prizes and think about it for just a moment, we didn't really know what the electron was until not that long ago. And then there's this whole field now called electronics where we use them to do all sorts of useful things. So can I tell you, hey, look, here's what you're going to use a quark for someday? I can't tell you that. Neither can anybody else. Mesons are very nice things to have to use in a lab to study quarks, because they form and they fall apart very quickly. So it gives you a chance to really look into that. And the more we understand about these smaller things, the more we can understand how to control them and how to actually perhaps use them for something. So when you get down to this fundamental level of science, sometimes you can't always point to it and go, oh, look, there's the application. That's easier on some of the earlier Nobel Prizes because more time has passed. We've done a lot more engineering since then. This one, 1947, this is getting down some really tiny stuff. And it really did lead to the entire field of, not by itself, but it was one of the things that led to a large amount of work in the field of particle physics. And this particular Nobel laureate was a large driving force behind the study of what is now modern day particle physics. So can I tell you, hey, look, here's what you're going to use it for? No, but we didn't know what we would use the proton for first either. And now we have proton therapy. So who knows? Maybe someday we'll find something. But this is one of those interesting prizes to me because it opened up a lot of fundamental studies that are still going on at places like CERN and others. There's entire meetings at Caltech and MIT and others about these types of particles. So they're truly interesting from a nature perspective, and maybe they'll help us figure out the universe, and maybe that'll lead us to something else. So this sort of research is important, and someday will get us somewhere. Don't forget to click like and subscribe, and we'll see you on the next video.